Okay, here's my final project video for ICS 635. I'm Will Hagen, and I generated a feature selection on protein embeddings. So yeah, I'm just gonna whip through this really quick because I just did one that's 10 minutes long. So we're using a 65 billion parameter transformer model with about 2,500 layers. And essentially what we're doing is we're taking protein sequences and we're inputting them into this transformer, and the embeddings have been shown, or these transformers have been shown to have really strong accuracy of outputting embeddings of protein sequences that correspond to their function or taxonomy or whatever. So a problem with these protein sequence embeddings is that some features in protein sequences can be ambiguous or erroneous and can skew the embeddings. So kind of feature selector to use on embeddings to improve the accuracy of our k-nearest neighbors predictions. This is what it looks like. We basically take an average from each layer, and then we take an average of all those averages to make the pooled embedding for one protein, and each amino acids pass through every layer of the transformer. So yeah, this is what they look like. Here's our problem that I spoke about. So as you can see with protein sequence A and protein sequence B, amino acids A1 through A3 and amino acids B1 through B3 are very similar. However, because of amino acids B4 and B5, the average pool embeddings of each protein are very different. And a lot of times, protein sequences can have amino acids that are erroneous or mutated or are just from a fast protein function. So ideally, we want to create a feature selector that can pick out the most important features that are output by the transformer. So yeah, basically I use a KNN on about 100 sequences for this project. And then I use a PCA, a kernel PCA, local linear embedding, sparse random projection, and then I generated a feature selector based off of the most standard deviation from each column. And I was thinking that if a column had more standard deviation, maybe it had more importance because each amino acid was really impacted by the by that layer. So yeah. All the curated embeddings were eventually ran through KNN, and I took the three nearest neighbors using cosine distance. And then we were classifying them into virus orthologous groups, which is a widely used way to classify proteins and viruses, which is what our proteins are. They're viral proteins. Yeah. So here are our scores, our accuracy. That's what I used as my way to score each feature selector. So when I use the entire embedding, I got a 70.1% accuracy. And as you can see, like my standard deviation feature selected terribly, and the random projection got about a 67. So if you're randomly selecting features, you get 67%. And then PCA did better than kernel PCA, which I'm kind of surprised about. And then the local linear embedding got about a 72%, which is our highest score. So this is an example of what our entire embedding looks like in the KNN. And then this is what it looks like when the features are reduced using the local linear embedding. Yeah, I mean, it speaks for itself that it organizes the data in a way that may be a little bit more, what's the word, like purposeful than like something like this. So yeah, so choosing features that are most important in reducing embedding to lower dimensional space using local linear embedding seems to work the best. I presume that it's outperforming other things because it's able to represent differences in high dimensional space between each layer, and models that are nonlinear like are better at capturing these relationships than linear models. And then I really need to scale up this data. And also should probably use a different classifier because virus orthologous groups is pretty ambiguous and oftentimes can lead to misrepresentations or misclassification. And then I also, so I don't know if you noticed, but I used only 10 components from each of my feature selection tools. And I just did this to see like the true performance of each model on the embeddings. But what I need to do is optimize each hyperparameter to hopefully get the most out of each feature selection tool. So yeah, thank you.